Testing, testing. I hope everyone can hear me. Okay. Okay, without wasting any much time, in today's video we'll be building these are our week seven. Welcome to day 7 of our 100 days of roast. And today's video we'll be building match sorted array. We'll be given two sorted integers arrays nums1 and nums2, match nums2 into nums1 as one sorted array. So for example, we have an input of two sorted integer arrays nums1 which contains 1 2 3 0 0, and that will be m equal to 3. Then we have nums2, then we have 2 5 6. Then the output we expect 1 2 2 3 5 6. So the zeros will be excluded. So here's the constraint. Minus 10 raised to power 9 is less than or equal to nums1 I, nums2 I, and okay, yeah, this is it. So note, the number of elements initialized in nums1 and nums2 are m and n respectively. You may assume that nums1 had enough space size that is equal to m plus n to hold additional elements with nums2. So as I said, we'll be using in our last video we use edulearn, and in today's video we'll also be using edulearn. So let me copy this and go to edulearn and paste it for a moment. So as you can see, I just prompted the AI. Okay, sorry. Okay, I just prompted the AI about what we'll be building today, and so now let's start. It says, okay, awesome. So you are diving into Rust with a 100-day challenge, and today's task is merging two sorted arrays. That's a fantastic problem to tackle as a beginner. It touches on fundamental concepts like arrays, sorting, and working with memory. Let's break it down step by step. Imagine you have two decks of cards, each sorted in ascending order. Your goal is to combine them into one sorted deck. How would you do it in real life? So it is, imagine you have two decks of cards, each sorted in ascending order. Your goal is to combine them into one sorted deck. How will you do it in real life? So for me, I think what I'll be doing will be um, arranging the like card together. Let's say we have which card we'll be talking about. Which card are we going to be talking about? Let's see. Yeah, normal card. So let's say I have a king and king there. So I think I'll sort it out into like I'll pick the two key from the card and then sort them together so they'll be together. Let me write it down. So I said I will arrange them and put the like cards together. So let's see what you can see. So it says that's the right idea. You are thinking about comparing the card and placing them in the correct order. And from our last video, it's about points for a very nice uh, idea. So now let's translate that into code. In the context of arrays, we'll be comparing elements from num1 and num2, placing them into num1 in sorted order. Here's a high-level plan. We'll start from the end. Since nums1 has extra space at the end, it's more efficient to fill it from the back. Compare the last elements of the initialized portions of nums1 and nums2. Then we'll place the larger elements, put the larger elements into the last available positions in nums1, and then we'll move the pointers. We'll adjust the pointers for num1 and num2 accordingly. Now we now repeat. We'll continue until we have a process all elements from either nums1 or nums2. Handle remaining elements. If there are any elements left in num2, copy them to the beginning of nums1. Let's start with the first step of coding this approach. Let's think about the indices we need to keep track of. What indices will be useful for traversing and modifying the arrays? For me, I don't actually know about. Okay, let's take it step by step again. It says the first step. Okay, let's start. Okay, now let's move on. Ready to start with the first step of coding this approach. Let's think about the indices. We will need to keep track of what indices will be useful for traversing and modifying the arrays. Okay, I think if I understand what the indices is talking about is I think the uh, to, to vector method or to vec method, I think. Okay, let's let me tell this I don't know, so you know what our step would be. Okay, basically it says indices are like addresses for elements within an array. They tell us the exact position of each value because we are working with arrays. We need a way to access and modify specific elements. So for this program, we use three indices, I, This will point to the last element in the initialized portion of num1, the part with valid numbers, not the extra zeros. Then you have J, this will point to the last element in num2, and then we have K, this will point to the last available position in the match array. Okay, let's continue. Okay, it says we know what indices we need. Let's think about how to initialize them. Since we know what indices we need now, I think we can initialize the indices ourselves. So initializing an indices is giving it, since indexes start with zero, we give it the zero value. So let's start. Okay, so now it says given that m is the number of initialized elements in nums1 and n is the number of elements in nums2, how do you set the initial value for I, j, and k? Remember, array indices start at 0. Okay, let me copy this, and then after copying that, I will now give it. Okay, okay, let's see what it has to say. It says, I see you have initialized I, j, and k to 0. That's good start in thinking about indices. But remember, our plan to start from the end of the arrays also. So I should point to the last element in the initialized portion of num1, j to the last element, and k to the last available position in the matched array. Given that n is the number of initialized elements in num1, and n is the number of elements in num2, can you adjust the initialization of I, j, and k to align with our start from the end strategy? Um, okay, I don't really grasp what you're saying, but I think you could say that okay, let me see it. Okay, geez, no problem at all. Let's walk through it together. Think of m and n as the length of the valid data in nums1 and nums2 respectively. So I should point to the last element in the initialized portion of nums1. If m is the number of initialized elements, what will be the index of the last element? Remember that array indices start at 0, so it will be n, I think. So similarly, G should point to the last element in nums2. So what happens is here is I think how to check how the length of an array is linked to the index of its last element. Okay, let me read this again. Maybe I'll understand. Let's go through it together. Think of m and n as the length of the valid data in nums1 and nums2. Okay, let's say I should point to the last element in the initialized portion of nums1. If m is the number of initialized elements, what will be the index of the last element? Thinking about something. Okay, it will use an example now to illustrate that. Suppose you have an array equal to 10, 20, 30. The length of this array is g, but the index of the last element is 30. Element 30 is 2. See how it's always one less than the length. So if m is the number of initialized elements in num1, then the index of the last element should be m minus I. Similarly, for num2, it will be n minus I, and for the match array, it will be m plus n minus 1, n minus 1, and now can you use this knowledge to initialize ig and k correctly? So let's do it. Let me see. Okay, I is equal to m minus 1, and then g equal to n minus 1, and k is equal to m plus n minus 1. So let's copy now and then send it to the AI, to Edulen. Let's see. Yes, exactly. That's how you correctly initialize the indices to start from the end of the arrays. I've already 5 points. Now that we have our indices set up, we need to iterate through the arrays and compare elements. What type of loop would be most suitable for this task, considering we want to continue as long as there are elements in both num1 and num2 to compare? Let me have this. Let me give it this. I think this loop, since this loop continues working until it's find. Okay, let me see. A loop could work, but we'll have to manually handle the loop termination. Yeah, conditions inside the loop. There's more idiomatic and readable way to express the condition as long as there are elements in both to compare. Okay, I think it already said the answer in the text here, but let me think. No, the answer is not here actually. So it says think about which loop structure in Rust allows you to specify a condition that must be true for the loop to continue. I think it is talking about while loop. So let's see. Yes, a while loop is perfect for this situation. It allows us to continue looping as long as a certain condition is true. Yeah, so it ordered me 2 points. In our case, we want to continue as long as both I and she are within the bound of their respective arrays, i.e., greater than or equal to 0. How will you write the condition for the while loop to ensure this? So I think I will see. Let me see. It says greater than or equal to 0. So I think while how will I put this? While um, it's even possible to have it in a one array or something, one loop, I think. It's even possible. We want to continue as long as both A, I, and J are within the bound for their respective arrays. That is greater than or equal to 0. How do you write the condition for the while loop to ensure this? Okay, I think it will be it will be a single while loop. I think, yeah. Okay, yeah, I think it will be a single while loop, and then we need to have an if else statement in it or something. But as long as I am J are within the bound of their respective arrays. So I think we'll be using okay, let me try it. While J is greater than or equal to 0, greater than or equal to 0. Yeah, it is greater than or equal to 0. And I, let me use I first. I don't know if it is. And G is greater than or equal to 0. Okay, now, okay, now I'll send it here as what I did while I is greater than 0. Okay, it says that exactly the condition we need. Wow, so I knew while loop. So it ensures that we only compare elements while both I and J are valid indices in their respective arrays. Now, inside the while loop, we need to compare the elements at nums 1 and nums 2 and place the larger one at nums 1 key. How do you write the code to do this comparison? So it says we write the code. Um, I think it will be if I think it will be we need to compare the elements of nums 1 I and nums 2 G. Nums 1 I and nums 2 G. So I think we'll write, oh my god, we need to compare the elements of nums 1 I and nums 2 J. So it will be like, I think if, uh, let me just say, I don't know. Let me see. So it says, let's break it down inside the while loop. We have two scenarios. Nums 1 I is greater than or equal to nums 2 J. In this case, we want to place nums 1 I at nums 1 key and then decrement both I and key. So nums J is greater than nums 1 I. In this case, we want to place nums 2 J at nums 1 key. So I think I started having the idea behind this. Nums 1 I is greater than or equal to increase nums 2 G. Then please, mm, I think I'll start decrement both I and K. I don't know. I don't know. I don't know. Nums 2 G is greater than nums 1 I. Nums 2 G. is greater than norms 1 I. How do you write an if statement inside the while loop to handle this scenario? Give it a try. Okay, so let's see. And as it says, I think if says if norms did norms unknown norms 1 I norms 1 I is greater than norms 2 G, then it says we want to place norms 1 I at norms 1 K and then decrement both I and G. Oh my god. I think then we'll now replace norms 1 G to be equal to norms 1 I. Then we'll now decrement I to something. Okay. I at norms 1 G. Okay. I think I get it now. So it will be something like norms 1 G is equal to norms 1 not equal to assign norms 1 I. I think I get it. So we'll now decrement. I think we'll now decrement I to something. I will now decrement both I and K. How can we decrement K here? I think to decrement K it will be here. I think it will be outside of this. If norms I is greater than norms J, then we'll now assign norms I to K and then reduce this. Hmm, Let me give it and see. Here's what I come up with. Okay. It made me something I like about this EduLearn is it makes me think very, very well. So it says that's a very good start. I see you on the right track with the comparison and placement logic. It have already made key points. However, there are a couple of things we need to adjust. In the if condition, you have norms I greater than norms 2J. I think there is a typo there. Also, we are decrementing k outside of the if statement, but k should always be decremented in each condition. Oh, in each condition, k should always be decremented. Does this say something about norms I greater than norms 2G? Should there be equal sign or something? Okay. I think I start getting this. So we still need to handle the case where nums 2j is greater than nums 1I. Nums 2j. Then I think we just need to use only else statement here or something. Okay, let me try else statement. Okay, let me give it now and see. Let me see whether. Okay. Okay, it says excellent. That's exactly what you need. You have correctly added else block to the handle the keys where nums 2j is greater than nums I. I've ordered you 5 points. Now let's think about what happens after the while loop finishes. The loop continues as long as there are elements in both nums1 and nums2. But what if one of the arrays runs out of element before the other? In our case, nums1 is the array that will store the match result, so we don't need to worry about what's left over in nums1. However, if there are any remaining elements in nums2, they need to be copied to the beginning of nums1. Why do we only need to worry about copying the remaining element from nums2 into nums1? I hope I'm right. Okay, we only need to worry about copying the remaining element from nums2 into nums1 because nums1 is where we are building the final sorted array. If there are elements left in nums2 after the while loop, it means they are smaller than all the elements already placed in nums1, and they need to be copied over to the beginning of nums1 to maintain the sorted order. I already made 3 points. Now, how do you write a while loop to copy the remaining element from nums2 to nums1? How will you write a while loop to copy the remaining element from nums2 to nums1? Oh my god, that's a very that's 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 hard one, I think. That's hard one to me. So a while loop, a while loop, and it's already tell me what to do, but doesn't actually tell me the answer. So I think how will you copy how will you how will you write a while loop to copy the remaining element from nums2 to nums1? From nums2 to nums1. I think I'll need to write a while loop for both I and J. I think let's see while I since I is while I less than is less than M, So it will now increment I and k. Then while g is less than n, it will increment g and k after assigning g to k, nums2 g to k. Is that something? Is that something? Is that something that rings in my bell? Nums1, yeah, nums1. Okay, let me try something. I will say while I is it will be less than, I think, yeah, less than m, then we will assign nums1 k to nums1 I or something like that. Okay, nums1 k, nums1 I. Then we'll now increment I and increment, okay, sorry, I, and then increment k. I think that's for I, and then for g, we'll now write a while loop, and then n, then we'll now assign them, assign nums k, nums j, I think. So we'll now assign nums j, nums 2g, okay, I haven't added that, nums 1, nums 1, I think, uh, yeah, and then we'll now increment g and increment k. Let me forward it and let's see. Okay, let's see. It says, okay, I see I've added two more while loops to handle the remaining elements in nums1 and nums2. I've already 4 points. However, there are a couple of things we need to consider. After the first while loop, either I or j will be less than 0, but not both at the same time. With that in mind, can you correct the while loops? After the first while loop, either I or j will be less than 0, but not both at the same time. Can you correct the while loop? Damn, I don't really get it. Either, can you correct the while loop? I don't really get what it says now. So it says the first while loop runs as long as both I and j are non-negative. Yeah, that's true. This means that when the loop finishes, at least one of them must be negative. If I is negative, it means we have processed all elements in the initialized portion of nums1. In this case, there might still be elements left in nums2 that needed to be copied over to nums1. If G is negative, it means we have processed all elements in nums2. In this case, all remaining elements in nums1 are already in the correct position. We don't need to do anything. So we only need to add a while loop to handle the case where there are remaining elements in nums2. That is, when J is non-negative, the second while loop you wrote is needed. doesn't make it doesn't make any sense to me. I don't get it. I don't get it. So it says let's say a different approach. Let's work through a specific example to see what happens to the indices I and j. Suppose n nums 1 is equal to 1 2 3 0 0 0. M is equal to 3 and nums 2 is equal to 2 5 6. N is equal to 3. Initially, I is equal to 2, j is equal to 2, and k is equal to 5. Then, in the first while loop, we compare nums 1, which is 3, and nums 2, which is 6. 6, since 6 is greater, we place 6 at nums 1, decrement j to 1, and decrement k to 4. We compare nums 1, 2, which is 3, and nums 2, 1, which is 5. Since 5 is greater, we place 5 at nums 1, 4. Decrement j to 0, and decrement k to 3. Now we compare nums 1, 2, which is 3, and nums 2, 0, which is 2. Since 3 is greater, we place 3 at nums 1. Okay. We only need check for remaining elements in nums 2. So what will happen is, let me remove this or what? Okay. Okay. Oh my god. So it says I don't have credits. Damn. Okay. As you can see, my credits just finished, and I don't know what to do now, and we can't continue without the credit. So I think what will happen is, let's go continue learning, and if you have the answer, and if you learn something, and then if you completed the code, you can teach us in the comment section and stuff like that, or you can DM me, or less or stuff like that. But I think while g is less than or equal to n, it will be the answer, I think. So have a great